concentration is a quality of solutions that we need to discuss. In general, we will find the concentration by taking the amount of solute and dividing by the amount of solution. Now, there are three ways to measure or talk about concentration. We can talk about the percentage concentration, and we can talk about very low concentrations like parts per million or parts per billion. Or we can have molarity. And we're going to talk about how to do percentage and molarity in class and in this video. This parts per million and parts per billion, I just want you to be familiar with that terminology. In order to talk about something in terms of parts per million, it means that you need to have 1,000,000 times less solute than you do solvent. And parts per billion means that you need to have 1,000,000,000 times less solute than you do the solvent. Now, there are some terms that we're going to be using in class: dilute, concentrated, and saturated. Now, saturated comes from our previous unit, and I don't want you to get concentrated and saturated confused. Concentrated means that I have a large amount of solute. It does not mean that my solution is saturated. I need to talk about dilute and concentrated in terms of how much solute I have in there. Dilute means that this solution is less concentrated than solution B. But concentrated means that solution B has more solute in it than solution A. So these two words are about comparison from one solution to another of the same solute, where saturated was more about, does it have the maximum amount of solute that it can hold. Percent concentration is going to be calculated in 4 different ways. We're going to go volume to volume if we have 2 liquids that we're comparing. So we might say that I have a 50% solution, and what I mean when I say 50% solution is that I have 50% of both of the liquids in that solution. I can have a weight to weight percentage, and I can use that whether I'm talking about solids or liquids. For example, 28% WW. This means that I have 280 grams of hydrochloric acid for every 1,000 grams of solution. Now notice that it does not say 1,000 grams of solvent. It is 1,000 grams of the entire solution is 280 grams of hydrochloric acid. So when we're making these solutions, we will use enough water to get to a liter. We're not going to add an entire liter of water to the amount of solute that we have. Now, if I have a solid that I'm dissolving into a liquid, I'm going to use this WV notation, and the VW is just an inverse of that same formula there. Molarity is the most common method that we're going to use for talking about concentration, and it is the number of moles of solute in 1 liter of solution. Again, it's a liter of the solution, not a liter of water or solvent. So our formula will be moles of solute over liter of solution. And our abbreviated formula then is molarity is moles per liter. Now, that molarity symbol, the M, here is capital M, and that's going to be important because in just a moment we'll see a lowercase m used for a different quality of solutions. Okay? Molality is that lowercase m I told you about, and it is the moles of solute per kilogram of solvent. This is the first time we've seen the word solvent talking about these formulas. Now, it's moles of solute per kilograms of solvent. Now, the only time we're going to really worry about molality is when we're using pressure, and we know that pressure is going to change. We want to talk about things in terms of its mass because we know its mass will not change, but volume can change for some substances under different pressures. Now, when we are creating our own solutions in class, what we're going to be doing is we're going to start with a concentrated solution, and I'm going to ask you to make a diluted solution of that substance. So we need this dilution calculation. We have MCVC equals MdVd. Now the M stands for the concentration. So if I give you a 12 molar concentration of hydrochloric acid, that would be the concentration. The volume would be how much of the hydrochloric acid I give you. So maybe I give you 500 milliliters of the 12 molar hydrochloric acid. Now the C and the D stand for initial and final. So we're going to have the amount of the original solution, its molarity, and its amount in volume, and we're going to multiply that together. And then what I want to do is I want to find how much of this solution do I need to make if I want to make a molarity that's different. So like if I wanted to take the 12 molar to 6, over here for the final molarity, I would put in the 6 and solve to find out how much volume I need of that original solution in order to create my diluted solution. So you see here in green it says we use this formula to calculate the amount of original solution needed to create a new, less concentrated solution.